Okay, so what I need you to do is pause it here and copy this down. And then we're going to take a look at how changing the compounding, how it affects the interest that you would get at the end of the time frame. So the initial amount invested was $2,500. So what we need to do first is step one says to write the original growth formula down. So I'm just going to put that over here. A of t equals A naught 1 plus r raised to the t. That's our normal growth formula. But as we change the compounding, two things are going to be modified. We have to modify the rate and we have to modify the time, because compounding affects how many times you're going to get interest, and the rate is affected by that as well. Now, on the previous slide, I let you know that you have to divide the interest by the number of times that you're compounding, and then you need to multiply the time or the exponent by the number of times you're compounding. So those are the two things that are going to be modified. But what I want to do is I want to start with what happens if we don't compound. What just happens in a year? So we would call that annually. Annually happens one time per year. And since we're multiplying and dividing by 1, nothing really changes in our growth formula. So what we would do is we would just take A of t equals, A naught 1 plus r to the t. And we're just going to fill in the information. We're trying to figure out how much our amount is going to be in the amount of time that they say. A naught is our initial investment. That's our $2,500. 1 plus our rate is 4. And remember, we have to change our rate to a decimal, from a percent to a decimal, so that's 0.04. And the time frame that they give us is 6 years. And again, we're dividing this by 1, so that doesn't change. And we're multiplying this by 1, so nothing changes. So that's why this is what usually happens. When you're doing a normal growth, it just means that you're doing your interest once. From here, what we're going to do is we're going to put this in the calculator. Okay, I'm going to clean this up just slightly. And then I'm going to type it in. So I have 2,500 times 1.04 raised to the 6th power. And our amount of money after 6 years is going to go from $2,500 to $3,163 and about 30 cents. Okay, so that's what happens when we compound once per year, our interest of 4%. Now, how does this change if we compound it a different amount? So we're going to go through and look at a couple different amounts so that you can understand how to do it. So what I'm going to do is we're going to look at semi-annually. Now, semi-annually means that you would compound twice, 2 times per year. Okay, and what's going to change is we're going to have our normal growth formula, except we have to take our rate and divide it by 2, because we're dividing it by the number of times, and then we're going to take our time and we're going to multiply it by 2. So that's how the formula gets modified. All other information is the same. So 2,500 is what we're starting with. 1 plus, our rate is 0.04, but we're going to divide it by 2, because semi-annually means 2 times. And then we still want 6 years, but we're going to multiply that by 2. So instead of it being happening in amount of 6 times, it's actually going to happen 12 times because we're doing it twice as often. So 6 times 2 is 12. So that part goes there. Now I'm going to clean this up a little bit. I have to take the 0.04 divided by 2 and then add 1 to it. So that's 1.02. And that's to the 12th. Now I can type it in. This outcome is going to give us more money, $3,170.60. Now, the difference in the amount is about $7, but it's free money. Nothing else has changed other than the amount of times that they're compounding your money. You're still doing it for 6 years, still the same amount to begin with, and you're gaining money on that interest. All right, moving to the next one. I want to show you quarterly. I'll move my paper up a little bit. So quarterly represents 4 times per year. Remember, 4 quarters and $1. So when we go to write that one, we're going to take our regular growth formula, A of t equals A naught, 1 plus R, but now we're dividing by 4 times. And we're taking our time and multiplying by 4 times because that's how many times we're doing it. Everything else stays the same. 2,500. 1 plus 0.04 divided by 4. And this is 6 times 4. 6 years, but we're doing it 4 more times a year. So this is going to end up being 24. Our interest rate is 0.04 divided by 4, and then add 1. So that's 1.01. And now we'll see what this one becomes. 2,500, 1.01, raised to the 24th power. $3,174.34. So I'm just typing this in to the calculator. So check it out. We're going from 3163 to 3174. We've officially gone $10 more just in interest. Okay. So it looks like the number of times that you're increasing is going to increase your interest over time. Next one I want to do is monthly. Now monthly should make a bigger difference because monthly we are going 12 times. There's 12 months in a year. I think you're getting the hint now, so skip a little bit. This is 1 plus R over 12 times T, or to the T times 12. Okay. So 2,500. 1 plus 0.04 over 12. 6 times 12. This is 72. So we're doing this 72 times instead of just once for an annual. We need 0.04 divided by 12 plus 1. Okay. This is 1.00333. We can probably go out that far. Don't just leave it 1.00 because that's not quite accurate. This is 0.0033 with a whole bunch of 3's repeating to the 72. 3,176 and 9 cents. Huh. Kind of expected that to be a little bit more. That's whatever. All right. So that's pretty much how you do it. The two things that change again is going to be your rate. You have to divide by the number of times. In your time, you have to multiply by the number of times. So make sure that you're doing that as we do the next few questions.